All right, folks. Second hour was a little squirrely today. We weren't able to focus real well. But you guys have the star quality of focus, and so therefore this will go great. Now that we've talked about limits existing, we can then move to continuity. And once we move to continuity, we can then move to what we call differentiability. And once we can move to differentiability, then we can take derivatives. And that's really the majority of what we learn in calculus is derivatives. So we're going to be there. But continuity, here's the dumb definition of continuity, okay? You can't write this on the test, but here's the dumb definition. If I want to graph a function, if I could graph that function without picking up my marker, then it's continuous. But if in order to graph the function you need to pick up your marker, then it is discontinuous. Continuous, discontinuous. What do you think about this one? Do you think this is continuous or discontinuous? No, discontinuous. How about this one? Discontinuous. Okay. What about this one? Yep, that one's continuous. Okay. Now, let's put forth a much stronger mathematical definition behind continuity. These three conditions you need to know, and they're not very difficult. A function f is said to be continuous at a number a, we're going to call that number a, if the limit as x approaches a of f of x is equal to f of a. Now you might wonder, what the heck does that mean? And so I'm a big proponent. I don't know if your textbook really lays this out real clearly, but I'm a big proponent of the three conditions that it satisfies. Number one, f of a must exist. So when you plug something in, you better get an output. If you don't, then there's no way that it's continuous. Second of all, the limit as x approaches a of f of x must exist. So if we can back up for a second and look at these graphs here, this one's continuous everywhere. This one's not. Does the function have a value for this a value? If I plug in a, do I get an output? Yeah, it's got a closed circle. But does the limit exist? Why? Different from the left than it is from the right. And so therefore the limit does not exist. So you can see how this gives you discontinuity. And then finally, the very last one, as long as you know the first two, the last one's very simple. It's just that 1 and 2 have to be the same. Or the limit as x goes to a of the function must be equal to whatever we get when we plug in the function value. So let's look at this very first graph here. Let's determine which x values the function is discontinuous. Can you determine an x value for which it's discontinuous? Good. So it's discontinuous at x is equal to -5. Now, let's state which of the three criteria it fails to meet. Okay, and you must have the criteria in that order and name it in order in which it fails. So we start with the first one. Does f of -5 exist? What is it? It's 3. Does the limit as x approaches -5 exist? What is it? It's 7. Are those the same? No, so it fails number 3. Give me another x value where it's discontinuous. 1. Does f of 1 exist? What is it? 6. Does the limit exist? No. Why? Different from the left and right. So it fails number 2. What's another spot where it's discontinuous? 4. Does f of 4 exist? No. So it fails. Now, I want to be clear. Some people have fought this over time. They've said, well, it also fails number 3, Mr. Gens. Yes, every single time it's discontinuous, it's going to fail number 3. I want to know which one does it fail first in the order of 1, 2, 3. I will not give you the credit on the test if you just simply say 3 every time, even though it does fail 3. I want to know in order which one does it fail. Is that clear? We all good? Okay, flip it over. We're going to skip example 2A and 2B. And we're going to do example 3 and 4, and that's all we need to do today, and you're going to then have time to work on an assignment, okay? And I'll show you the schedule for the rest of the week. It says, explain why the function is discontinuous at the number A. So they're telling that these functions are discontinuous. We just want to sketch a graph. This is a rational function, but which value is it obviously discontinuous at? Why is it discontinuous at 2? Right. If you notice, if you plug in 2, you get 0 over 0, which tells us that there should probably be a gap. And we'll look at that when we get back. Go enjoy your lunch, get some brain food, come back. Okay, let's pick up. It says, explain why the function is discontinuous at a given number A. Sketch a graph of the function. So we have x squared minus 4 over x minus 2. You guys said that it's discontinuous at 2 because if you plug in 2, you get 0 in the denominator. You're absolutely right, okay? But we want to generate a graph. And maybe you recognize that this factors x plus 2 times x minus 2 over x minus 2. So here's the deal. It wants to look like x plus 2. What is the only way in which it differs from the graph of x plus 2? Yep. So there we go. So it's got that gap right there. How did I know that that gap happened at 2, 4? Because you simply plug in 2 and you get... Yeah. Okay. All right. Now, the question is, which of the 3 requirements does it fail? The first requirement is, does f of a exist? So if I plug in 2, do I get an output? No. So it fails number 1. Because when you plug in 2, you get 0 over 0. And that's, yep, there's no value. This is not part of its domain. All right, we'll look at the second set. X plus 1 for x less than 0 and square root of x for x greater than or equal to 0. So x plus 1, I'm going to plug in 0. And when I do, I get 1. So I plug in 0, I get 1. Open or close circle? Open, and it's going to look like this, right? Next one, I plug in 0, and you get open or close circle. Kind of head on off like that. So it says that it's discontinuous at 0. Let's check. Does f of 0 exist? What is f of 0? It is 0. Does the limit as x goes to 0 exist? No, it does not. It does not exist because, yep, the one-sided limits exist, but because they are different, very good. So we have fails number 2. That's all we're looking for. Our last example for the day is going to be for A and B. It says the following functions have a removable discontinuity for a point A. Fill the discontinuity by writing a piecewise function. So this did not go well second hour. Let me kind of prime your brain so that you're ready for this. This is an example of a removable discontinuity. This is not a removable discontinuity. Suppose that you wanted to fill this spot right here. What point would fill this spot? What coordinate? Yeah, so that's kind of what we want to make happen. So as you look at this function right here, if we plug in -3, okay, a equals -3. I have -3 squared is 9, minus 9 is 0, and -3 plus 3 is 0. You get 0 over 0. So everybody agree that it's discontinuous at -3. If you plug in -3, you do not get an output. It fails requirement number 1. Well, it says let's fill that discontinuity so it's continuous all the way through. So I'll write a new function, g of x. And we're going to let g of x equal x squared minus 9 over x plus 3 for all x values other than -3. So we're okay to plug in any other number, right? But when x is -3, what should our y value be to fill that discontinuity? So that it's exactly what we did here, okay? We have this weird function going on. It's got this hole, and we select this point, 2, 4, and we're good to go. So you got what? How'd you get -6? So I got x plus 3 over x minus 3. So it wants to look like x minus 3. So if you would plug in -3 to that, you get that -6 value. And in effect, that would fill the discontinuity. Got it? Got it? Okay. Letter B. Do you agree it's discontinuous at a equals 1? We get 0 over 0. It is a removable discontinuity. So let h of x be equal to x cubed minus 1 over x minus 1 for all x values not equal to 1. But when x is equal to 1, what should we put in its place? Yeah, so we're going to give you a way to work around that. So this is the difference of cubes, which is x minus 1. So it's just like it looks, cubed root of x cubed and cubed root of 1. And you square the front, you square the back, and you multiply the two together and make it opposite sign. So if you plug 1 into that, what would you get? 3. We're going to look a little bit more at that in just a second. But right now, some of you might forget how to factor cubes in that type of situation. Can I show you a way to work around that? Well, if I were to divide those, the solution is 1, right? So you got 1, 0, 0, and -1. Just divide it out. 1, 1, 1, 1, 1, 1, 0. So x squared plus x plus 1. And that's what you have, right? So your synthetic division works as well as you divide that out. Last thing I'm going to do is just try to make my case just a little bit more clear, and I'll give you your assignment. If I take that x cubed minus 1, and I divide it by the quantity x minus 1, and I'm going to zoom as a decimal, number 4, you can see I do get that parabola, and what do you notice? As soon as I get to an x value of 1, you can see that it disappears. And then I pick up the 1 right after that. Sure enough, I have that gap right there. Okay? All right, so your assignment is the following. Okay, so when you look at your book, the directions for 3 and 4 are going to be different than what we did in class. They approach it from a little bit different standpoint. I don't see how the way that they're asking the question is really going to help us prepare any more for the AP exam or anything else. I think that you're best off if you just simply identify where it's discontinuous and then identify which one of the 3 rules it fails to meet. 15 through 20 are not easy problems. These are harder, okay? So just please be ready for that, okay? If you need help on Thursday or Friday working through some of those challenges, you know, a lot of people have questions on those, okay? And 41 just A, C, and D. Okay? So I will hand out, I already have your study guide ready. I already have your homework cover sheet ready. Okay? The test is when? Tuesday. So we are going to finish 2.5 tomorrow. We'll be doing 2.6 on Thursday. You will have Friday to work and Monday to work. Test on Tuesday. Conferences are on what day? Thursday.